This is Junk Dump, and I'm back. This time I'm going to be looking at a tool battery charger, and I'm sure most of you have these sitting around. Sometimes things go wrong with them. Let's see if we can repair this one with $6 in parts. And let's start by taking this apart. I'm going to remove the foot pads, and then there's going to be some torque screws underneath. This charger uses the T20H. Those are tamper-proof torque bits. Regular T20 is not going to fit in there because of that nub, and there's no hole in your Torx bit. It just won't fit down in, so you're going to have to use a T20H. And here we have a ribbon cable, and that just brings some power and some signal wires up to the display on the top of the charger. It looks like we have a massive failure in this IC here. It's completely blown apart. That's going to be your switching AC-DC converter for this unit. This is a common problem that I find in electronics. The capacitors are bulging. That means that there was a pressure that built up inside of them, and that's not good. So whenever I see this, it's time to replace them. Nothing else really jumps out at me as being a problem, so I think I'm just going to replace those two components and give it a shot. Here I'm just going to mark the back here so that I know which pins I'm going to desolder. This is a pretty common desoldering tool. The tip just gets hot, liquidates that solder, and then as you release the bulb, it sucks up the solder, making a nice clean area for you to remove any components. And here's a little bit of a close-up on that top of the capacitor. Whenever you see a capacitor with a bulging top like this, it's probably best that you just replace it. Here I'm just trying to illustrate what the difference is between a capacitor that's good and still flat on the top versus this one where you can see that tiny bit of bulging. Now I'm going to desolder that AC to DC converter, and that one I believe has 6 pins. Here I'm removing the IC from the heatsink. Oh, IC stands for integrated circuit. That's any of these little black packages that you see with the pins coming out of them. Now I'm grabbing onto the feet and just levering them out. Massive failure in this IC here. It's completely blown apart. I'm just going to use a little bit of alcohol on a cloth here and just clean off the backing area. That switching IC gets pretty hot, and to make it cool down easier, they have this thermal paste that connects it to the heatsink, and that's going to help dissipate that heat into the plate quicker and more efficiently. I'm cleaning off the old thermal paste to make way for some new stuff. Now I'm going to remove that heatsink from the board. This is the new AC-DC converter. I looked up the IC online and got a newer, this is an upgraded version, and you'll often find that if you're trying to replace components in anything like this. Here's one of the few times the shaky hands actually help as I'm dabbing some thermal paste onto the backing. Just a nice even coating. Now I'm setting that IC on the heat sink, and I'll install it in place with its screw. After making some minor adjustments to the feet, I'm just going to wiggle them in to place and make sure that all those feet end up in the through holes. With the IC legs properly installed in the through holes, now I'm going to reinstall the heatsink, and that will help hold it in place. As you can imagine, with shaky hands, soldering is quite difficult, but I seem to manage here, and I'm soldering in the IC. When replacing capacitors, sometimes you can get away with getting a higher voltage rating, but you always want your capacitance to be the same. And here it's 1000 microfarads. Now again, I'm just putting the tabs right through the through holes. Once those tabs are through, I bend those leg ends, and that helps hold it in place while I'm soldering it on the other side. With the soldering complete, I'm just going to snip off the excess. Now it's time to reverse the process, and we're going to reinstall everything in place. I'm going to start with the board. Try not to forget that LED panel. That clip goes right back in the way it came out. Now I'm just reinstalling the screws. Make sure you don't over tighten these. Remember, it's just in plastic, so snugging them up is just fine. The feet just press back into place. Now I'm going to test it to see if this fix went well or not. Plugging it in, and sure enough, it lights up. That's a good start. And with the battery in place, it's flashing, which means it's charging, and it looks like this one's going to be just fine. So there you have it. In this case, it only took $6 in parts to repair this charger. The chargers are fairly cheap. This one's like a $35 charger. But the point is that there's now not one of these sitting in the trash or in the ground somewhere, and I was able to save it, and I'm sure it'll last just as long as it did the first time. Once again, I'm Junked Up, and thank you for watching. This has been a tool battery charger repair worth $6.